Today we're going to be looking at the equation of a circle. But before we do that, there's a concept that we're going to need to understand called completing the square. And so we're kind of going to go about this a little bit backwards at first. We're going to go back and review some previous skills, and then we're going to talk about how does this apply to a circle. So the objective here is to find the center and the radius of a circle using the completing the square method. So notice it says that we're going to solve this perfect square trinomial equation and find the solutions. So basically, when you have a perfect square trinomial, what that means is that you have three terms that can be factored into two of the exact same factors. So if I look at the left side of this equation here, that x squared minus 10x plus 25, if I were to try to factor that, I would need factors that multiply to 25 that add to negative 10, which end up being negative 5 and negative 5. So because those are exactly the same factor, what that tells me is I'm going to end up with the same factor squared. So basically here I would have x minus 5 times x minus 5 using my shortcut when a is 1, which looks like this. However, since this is the same factor twice, I can rewrite that as a square so that it looks something like that. So you may or may not have learned this in Algebra 1, but another way to solve a quadratic is to use the perfect square method. And we're going to dig into that a little bit deeper here in just a moment. But if we were to try to solve this equation for x, to get rid of that squared, I'm going to take a square root of both sides. That's going to leave me just with that x minus 5, so I'm going to delete the parentheses essentially here. But remember, when you take a square root, you have both the positive and the negative answer here. So it could be positive or negative 3. So at this point, I'm going to break this up into two equations. Either x minus 5 equals a positive 3, or x minus 5 equals a negative 3, and x either equals 8 or 2. So this is just another way to solve a quadratic, is if you have a perfect square trinomial on the left side of your equal sign, you can factor it, take a square root, and end up with your two solutions. So let's try one more together, and then we'll get a little closer to talking about what this has to do with circles. So on the left side of this equation here, we have 100 as our a times c value and negative 20 as our b value. So negative 10 and negative 10 are our two factorable solutions. So x minus 10 times x minus 10 would equal 7. And x minus 10 squared equals 7. Again, if we're solving for x here, we're going to take a square root of both sides so that we have x minus 10 equals positive or negative square root of 7. Now, since 7 is not a perfect square, we're just going to carry that along in its simplest radical form. And to get x by itself, I would add 10 to both sides, so I end up with 10 plus or minus the square root of 7. And as ugly as that is, that would be our final answer in its simplest radical form. So again, perfect square trinomials are just another way to solve a quadratic. Just like normally we would factor or use the quadratic formula, this is a third option that we do have, or a third tool in our toolbox. But this perfect square trinomial has a special pattern that happens every time. So if you notice, there's a relationship between our b value and our c value every time. So let's talk about what's happening. Every time we have a perfect square trinomial, the b value here is related to the c value in a very specific way. So we're going to now use this option for solving a quadratic by forcing the left side of the equation to be a perfect square trinomial, right? Because that doesn't always happen. So we're going to rewrite the equation in the format x squared plus bx equals c. In other words, we're going to move any constants to the right side of the equation. Then we're going to complete the square by adding the b term over 2 squared. So if we look back at what was happening here, if I take half of negative 10, that's negative 5. Negative 5 squared is 25. So that was the c value here. If I take half of negative 20, that's negative 10. Negative 10 squared is 100. So that gives me my perfect square trinomials each time. So what I want to look for is I want to look at, is this c value half of the b value squared? So my b value is 6. So if I take half of 6, that's 3. And if I square that, it's 9. And that's not what I have next to that. So we're going to reject that c value. We're going to add that 7 to the other side. But I'm going to leave a little bit of space here. So again, half of my b value, half of 6 is 3. 3 squared is 9. So I'm going to force this to be a perfect square trinomial by adding 9 to this quadratic. But what I do to one side, I have to do to the other. So now I have x squared plus 6x plus 9 equals 25. And if I look for factors of 9 that add to 6, I've now forced this so that it's the same number twice. So I'm going to end up with x plus 3 times x plus 3, or x plus 3 squared equals 25. And I can take the square root of both sides here, so that I have x plus 3 equals, the square root of 25 is 5, but it could be positive 5 or negative 5. Then I'm going to break it into 2 steps. X plus 3 equals 5, meaning x is 2. Or x plus 3 equals negative 5, meaning x is negative 8. So those would be my 2 solutions to this quadratic. So again, completing the square is just an alternative method for how to solve a quadratic, just like factoring or using the quadratic formula. So this is another tool that we have in our toolbox for solving. For sake of time, we're going to go ahead and move us forward just a little bit here. We're going to try number 7 together. So remember, you want to take the b value cut in half and squared and make sure that that is your c value so that it's forced to be a perfect square trinomial. So half of negative 20 is negative 10. Negative 10 squared is 100, and that's not my c value here. So I'm going to move that 13 to the other side. So I've got negative 104 plus 13. And I'm going to end up with negative 91. However, we already said to complete the square, half of negative 20 is negative 10. Negative 10 squared is 100. So to complete this square, I need to add 100. But what I do to one side, I have to do to the other. Now on the left side, I now need factors of 100 that add to negative 20. So that's going to be negative 10 and negative 10. So I have the same factor twice, which means that it's a square factor. Negative 91 plus 100 is 9. Our next step is to take our square root of both sides. So x minus 10 equals plus or minus 3. So either x minus 10 equals a positive 3 or x minus 10 equals negative 3. So x is either 13 or 7. So guys, final thing here, this is just another way to solve quadratics, but completing the square is going to be important to us for writing the equation of a circle. So before we begin the next section here, and we kind of put all of this together, the equation of a circle has this standard format: x plus h all squared plus y minus k all squared equals your radius squared. And that h and k represent your center of the circle, whereas your r, like I said, represents your radius squared. Now do notice here that we do have a negative symbol here. So whenever I bring out the h and k values, because there's a negative in the standard format, that tells me I need to change the sign of that number to identify the center. So when I change the sign of these two values here, that means my center is at 16, negative 9. And I want to think about what number squared would give me 144. And that tells me that R is 12. So I've now identified where the center is and what the radius is. So you'll notice here, guys, we've got two perfect squares. So we're now going to go through the process here in just a moment of creating the equation of a circle by using the method of completing the square. So with that in mind here, we're going to use a very similar process to what we did before. I'm going to get all of my x's together, and I'm going to leave space to complete the square for x. Then I'm going to get all of my y's together, and I'm going to leave a little space to complete the y. All of that equals 8. Now notice here, if I'm adding something on the left, I need to add it also on the right. So I'm going to go ahead and put a blank space for both of those. So looking at the x component, remember that we want to take the b value divided by 2 and squared. So 8 divided by 2 is 4. 4 squared is 16. So to complete the square of x, I need to add 16 to both sides. For the y component, negative 10 divided by 2 is negative 5. Negative 5 squared is 25. So I'm going to add 25 to both sides to complete the square of y. Just focusing on the x component, I now need factors of 16 that add to 8. So that's 4 and 4, which means that factor is squared. Then I want to look at the y values. I need factors of 25 that add to negative 10. That's negative 5 and negative 5, or negative 5 with a squared around it. And then on the right side equals 8 plus 16 plus 25, which is 49. So what I've now done is I've written the equation of this circle so that I can easily identify the center and the radius. So my final step, now that it's in this format, is to look at the values of h and k, but remember that we change the sign of that when we bring it out because our standard format has a minus. That means that we're going to have to change the sign when we bring that information out. So negative 4, 5 is our center of this circle, and our radius is going to be whatever the square root of 49 is, which is 7. Now notice here, when I took that square root, I did not put plus or minus 7, right? Because a radius cannot have a negative length. So we're only looking at that positive value. So r equals 7, and our center is negative 4, 5. So let's take a look at the first one. Very easily is already in that format for us where it's easy to pick out the h and k, or the center values. So negative 8, negative 3 is our center. And our radius would be the square root of 121, which is positive or negative 11. But because this is a distance, cannot be negative, so we've got our two pieces. So what I'm going to do with the remainder of this screen is I'm going to take a look at B, and I'm going to write B so that I can easily identify the center and the radius. So remember, collect your x's together. So I've got an x squared and a negative 6x. I'm going to have to add something to complete that square, so I'm going to put a blank there. Collect your y's together. We're going to have to add something there to complete that square, equals 8. Now remember, this is the most commonly forgotten part. Whatever you do to one side, you have to do to the other. So don't forget that we've got to add that number on both sides. So half of negative 6 squared is 9. So I'm going to add 9 to both sides. Half of 14 squared is going to be 49. And I'm going to add that to both sides. I'm going to factor the x like I normally would. So factors of 9 that add to -6 are -3 and -3. Then I'm going to factor the y's like I normally would. Factors of 49 that add to 14 are 7 and 7. And I have 8, 9, and 49 all being added together to get 66. Now that I've got it in its standard format, I can easily identify that the center is at +3, -7, and my radius squared equals 66. So I need to take a square root of both sides. However, the square root of 66 cannot be simplified, so I would leave that as the square root of 66 so that it's in its simplest radical form. Let's do one more together, and then we will move forward. So with this one, we've got that 1 that's already there. So I can either reject that 1, meaning I can subtract it to the other side, or I can verify, is that actually the number I need? So if I take half of 2 and square it, that is 1. So this is already ready and primed for me to factor it. It's already in that perfect square trinomial format. So factors of 1 that add to 2 are 1 and 1. Notice my y doesn't have any other term. It's just got a y squared. So it's already a perfect square on its own. So when I identify the center and the radius of something like this, I do not have a y coordinate there. So I'm going to assume that that's a 0, and I'm going to change the sign of h, since that's our standard format. My r squared equals 4, which means my radius is 2. And then I've got the center and the radius identified. Now, for those of you who have TI-84 calculators, you are typically able to graph the equation of a circle or a line or any other format using that calculator. However, for sake of time today, we're not going to talk about how to actually use that y equals equation, because in this particular case, it's not solved for y. But we are going to talk about here in just a moment what this would look like on a graph without using a calculator. Oops. Sorry guys, I've got some old notes in here. So let's talk for just a moment about what this would look like. So if we've got an x and a y coordinate plane, and we wanted to graph this particular circle, what this says is go to -1, 0, and that is your center of the circle. Come out with a radius of 2. So we can go right 2, we can go left 2, we can go up 2, and we can go down 2, and I can sketch that circle. Now because I made my own graph, you'll notice that's not a perfect circle. However, if we were to have had a perfectly gridded piece of paper, we could graph that very, very easily using this information. So kind of going back here, let's look at some of our other ones. I won't ever ask you to graph something like this, where you've got a square root as your radius, because we can't count that. But I might ask you to graph something like this one, where you have a radius of 11. Let's double back just a little bit further. I'm going to try to find us one that's not quite such a large radius for us to practice graphing together. It looks like that might be the only one that's got a pretty small number. But let's talk about this one here. If we were to graph this particular circle, we would want to start by placing our center at -4, 5. And then if our radius is 7, that's the distance on all sides. So I could count up 7, I could count down 7 from the center, left 7 from the center, and right 7 from the center. And to the best of my ability, I would sketch that circle. Guys, this is all of our notes for today. If you have any questions or concerns, please feel free to email me. Have a great day.